All right, so in this video, we're going to continue with 4.5 simulation, and we're going to now do a stock price simulation example. So we're going to do an example with simulating stock prices. So remember, we're going to do log returns. So we're going to say RT, it's not very good R, so RT is going to be a log return. So this is a log return. And we're going to say that the returns are normally distributed. So we're going to simulate our returns. We're going to say that they're normally distributed, and let's say that let's say RT. Let's say return for RT. So let's say this is today. Let's say this is closing price today, or a return from close today. We're going to say it's equal to its mean. Let's say its mean. Let's do its mean times delta t. So this would be, if this was an annual mean and this was a log return, you can divide by 252. That would make it daily. So this is why we like log returns. And then let's say it's going to be plus some noise, some randomness. Let's say zt, but let's say it's going to be plus it's going to be proportional to the standard deviation. So the volatility, and multiplied by delta t squared multiplied by z of t, where z, t, follows a standard normal distribution. So the mean is 0 and the variance and standard deviation are 1. So the reason why we do this, the reason why, so our mean, if we multiply everything to by delta t. So if we make this daily, so say mu, this is the annual return. Say this is an annual return. Then to make it daily, we multiply by delta t, the change in time. So if it's annual and it's log return, then you could divide by 12. That would make it monthly. Divide by 252, or the number of trading days in a year, and it would make it daily. And now for our variance, let's say, so for variance, you would multiply by delta t. And the reason why we square root it is if you take the square root of sigma squared times delta t, this would be equal to sigma times the square root of delta t. So that's where that comes from. And again, this is just to make it daily numbers, or to make it in terms of whatever you want. But if we're trying to do daily and we already have daily return and daily standard deviation, then it doesn't matter too much. So let's go over how we're going to use this. Let's go over how we're going to use it. So this is our model, and let's say we want to predict, or we want to simulate tomorrow's stock return, or let's say we want to simulate tomorrow's stock price. First, you have to simulate tomorrow's stock return. So return of tomorrow would be equal to its mean, daily mean, plus, and the volatility of the stock, something to make it daily. So if this is already in daily numbers, then it would be fine. So let's just go ahead and make everything daily. So we'll make it all daily. So let's say this is the daily return plus the daily volatility multiplied by zt, or z at t plus 1. And this is going to be what we're simulating. We're simulating z, which is going to follow a standard normal distribution. So now we can, with this, we could potentially simulate 30 days in the future of stock returns. But we don't only care about stock returns. We really want the stock price. So remember that our stock return, our log return, is going to be the natural log of stock price t divided by st minus 1. So this, if we want to simulate tomorrow's stock price, so the natural log of, let's right over here. So know that the return of tomorrow, t plus 1, would be equal to the natural log of the stock price of tomorrow, or the next period, divided by the stock price of the current period. So if we want to simulate tomorrow or the next period's stock price, we would all we'd have to do is plug it in. So after we simulate the return, we would and just plug it in. We'd have to do a little bit of algebra. So the log return would be equal to, let's say this is daily. So tomorrow's stock price, or the tomorrow's stock return would be equal to, if it's normally distributed, then would be equal to the daily average plus the daily volatility multiplied by some random number that we would simulate. So now, if we want to try to simulate tomorrow's stock price, you could do e both sides to the power of v. That would get rid of the log. So you do e to the power of all of this, e to the power of all of that. The natural log goes away. You're left with you're left with the stock price of tomorrow divided by the stock price today would be equal to e to the power of our daily stock return plus our daily volatility multiplied by tomorrow's random number, the z. This is the random term. Now you take it a step further, multiply both sides by today's stock price, or the recent period, and now we get stock price of tomorrow equal to stock price today multiplied by e to the power of our daily mean plus our volatility and z of tomorrow. So this is what we're going to simulate. The z is what we're simulating. The volatility and the mean will be found. They are going to be calculated. They're going to be determined. They're going to be calculated. So whenever we do this, whenever we go and create this simulation, so whenever we run this simulation in Python, we're going to get, remember our model, or our formula for a stock return. So if we want tomorrow's, we want to find tomorrow's stock return. So st plus 1, or I'm sorry, rt plus 1 should be equal to our daily stock return, our daily average plus the daily volatility multiplied by our z of t plus 1, where z is going to follow a standard normal distribution. That'll be important when we go to simulate this. But the model that we're going to use is going to be to calculate the price, or to estimate the price. So tomorrow's stock price will be equal to today's stock price to the power of our daily return plus daily volatility multiplied by z t plus 1. So tomorrow's noise, tomorrow's randomness. And you take it forward. So let's say we want 30 days in the future. So s t plus 30 would be equal to s of the day before, so t plus 29, multiplied by e to the power of our daily mean return plus our daily volatility multiplied by z, which is what we're going to simulate, of z t plus 30. So whenever we do this, we're going to have to create a loop. We're going to create a loop for each path. We're going to create a loop for each to go through each day. So let's say this is t, and this is going to be, so this is our date, or our day, time, and up here we have our price, stock price. Let's say historically it may have looked like this. And then at t, if we simulate a bunch of paths, they could look like this. You get one path here, and that would be one loop. We have another loop for another path, and a loop for another path. And let's say we do it 5 times for 5 different paths, and you get something that would look kind of like this. We're going to simulate everything after this. All of this is going to be in the future. So this would be t plus 1, t plus 2, t plus 3, and all the way to maybe t plus 30. So so whenever this is what we're going to do in Python. So I think now we've gone over the math and what the model is going to look at or look like. So now we can the next video we'll do it in Python.